enhanced EIGRP. So EIGRP is Cisco's proprietary protocol. So before start with the implementation, we'll see some information related to EIGRP. Then we'll start with the implementation of EIGRP as well as EIGRP and RIP on the same network. So EIGRP, as we have seen the routing protocols, that is OSPF, then RIP version 1 and version 2. So in EIGRP, it's a hybrid type of protocol. So first we'll see the characteristics of EIGRP protocol. So it's Cisco's proprietary routing protocol, means this protocol can be used in Cisco's routers only, not any other routers. So it is based on EIGRP routing protocol, that is Interior Gateway Routing Protocol. It's an enhanced version of EIGRP protocol. Then in comparison of EIGRP, it provides faster convergence time, then superior handling of routing loops and improved scalability. So that we are going to see. Then it was released in 1994. It is hybrid routing protocol. Why it is called as hybrid? Because it has the characteristics of both, that is distance vector and link state protocols. So it uses dual algorithm. Up till now we have seen shortest path algorithm is used to find out the best path. But in EIGRP, dual algorithm is used, that is diffusing update algorithm, to select the best path. It uses multicast for routing updates. Then EIGRP supports IP, both that IPv4 and IPv6, AppleTalk and IPX routing routed protocols. Then it includes subnet mask information in routing updates. Then it supports route summarization and discontinuous networks. It supports VLSM, variable length subnet mask, and CIDR, that is classless interdomain routing. It supports load balancing across 6 routers for a single destination. So these are some features of EIGRP routing protocol. Now EIGRP, it maintains 3 tables basically at the router for ultra fast convergence. First is neighbor table, then topology table, and routing table. So neighbor table, in that EIGRP shares routing information only with neighbors. As like in OSPF, in EIGRP also neighborhood relationship is established by sending hello packet. So EIGRP shares routing information only with neighbors. It finds out the neighbor and shares the routing information. That's why EIGRP is known as that hybrid protocol, because it follow that RIP as well as OSPF. So it has features of distance vector as well as link state. So to know who the neighbor are, it uses the neighbor table. Next is topology table. Topology table means EIGRP uses this table to store all routes which learn from the neighbors. So it contains a list of all destinations and routes advertised by neighboring routers. So EIGRP select best route for each destination from the list. So complete topology is stored, that all the routes which are learned by the neighbors, that those are maintained in topology table. And routing table, as you all know, so that EIGRP stores single best route for each destination in this table. So single best route or single best successor route, we can say, that will be stored in a table. So router uses this table to forward the packet. By referring the routing table only, the node is going to forward the packet towards destination. Now the metric used in EIGRP, as we have seen in OSPF, metric is cost. Even we have seen that formula for cost calculation in OSPF, that is 10⁻⁸ divided by that bandwidth in BPS. So that was formula for OSPF to calculate the cost. So metric is a metric for OSPF is a cost. Then in case of RIP, metric was hop count. Now in case of EIGRP uses metric to select best route from all available routes for the destination metric, which has 5 components. So even in EIGRP, cost is a metric. So these are the 5 components of the metrics, that is bandwidth, load, delay, reliability, and maximum transmission unit, that is MTU. So from these, only bandwidth and delay are by default enabled. So remaining components, we need to enable it explicitly by giving command. So by default, bandwidth and delay are enabled in case of EIGRP. Now here that we are going to discuss about AD value. AD is administrative distance. So router use AD value to select the best path among these routes, because one router can have multiple paths towards destination. So from those multiple paths, best path will be selected towards destination. So router uses AD value to select the best path among these routes. So lower AD value has more trustworthiness, right? So that as the value is lowest, so that protocol is the best protocol. So now you can see 0 AD value means what, it is directly connected, there is no need of any routing protocols. If the AD value is 0 or 1, so that is static route. If AD value is 19, means that's the EIGRP interior. EIGRP are of two types, interior and exterior EIGRP. Interior, that is within an autonomous system. Exterior, which is between autonomous systems. So exterior AD value is 170, interior AD value is 90. Then OSPF 110. In RIP, it is 120. And if that source is unknown, then that AD value is 255. So the best protocol among these given list, so that is EIGRP interior. Why? Because the AD value of the EIGRP is lowest in this. 0 is lowest, but it is directly connected, so there is no need of any routing protocol to go towards that destination. So 0 AD value. Static route 0 or 1. So among these 5, EIGRP interior is the best one. Now the K values. So just now we have seen these are the metric component, that is bandwidth, load, delay, reliability and MTU. These are the metric components. So with K values, we can control which component should be used in a route metric calculation. So with the K value, we can control which component should be used in a route metric calculation. While calculating the route metric, which K value should be considered. So that can be decided, or that can be in a controlled manner it is given. So here K values, K1 is bandwidth, K2 load, K3 delay, K4 reliability and K5 is MTU. So condition is what, two routers must use same K value. Then only they can become a neighbor. Even though the connection is there, but the router 1 is using 3K values and router 2 is using we can say 2K values, so they cannot become a neighbor of each other. So what is given here, for example, if one router is using 3K values, that is K1, K2, K3, so while second router is using default K values K1 and K3, so then those two routers will never become a neighbor. Why? Because their K values are different. So K value should be same between two routers. Now EIGRP metric calculation formula, you can see here, that is bandwidth is equal to 10⁻⁷ divided by list bandwidth of route. So that list bandwidth of route, how to check the bandwidth of the interface, that I will tell you. So that list bandwidth is given in kbps. So 10⁻⁷ divided by list bandwidth plus cumulative delay, means that particular route or that particular we can say destination that may be on 2-3 hops. So we need to consider that delay of each outgoing interface there. So cumulative delay of route is what, sum of all outgoing interfaces delay. So use interface the default delay if not set through the delay command. When we have to use default delay, if the delay is not set through explicit delay commands, so it is expressed in terms of tens of microseconds. Means if it is 20,000 microseconds, so in the formula you need to use delay that is 2000 only, right? So it is expressed in terms of tens of microsecond. So cumulative delay means we need to add delay of each and every outgoing interface here. So metric is equal to 10⁻⁷ divided by list bandwidth plus cumulative delay into 256. So here one example is given, that show IP route command. You already aware with this command. To see the routing table, we use this command. Now to see the routing table through EIGRP, so we need to specify that protocol name. So protocol name is specified here. So DDD means EIGRP. Why D? Because it uses dual algorithm to we can say set the shortest path. So dual algorithm is used to select the best path. So DDD. So 30, 40, 50, these are example network. For example, now you can see here 40.0.0.0, that destination, which is not directly connected. That's why C is not here. It is D. So D is what? It is connected by using EIGRP routing protocol. So 90 is AD value. So we are going to see how this cost is calculated. How this cost is calculated. So we'll see here. Now you can see the three routers are given here. This is source and this router is destination. So how to check the bandwidth of a particular interface? So there is a command like show interfaces, serial, whatever is the name of that interface, you can mention here if you want to see the information regarding that interface only. And if you want to see the information regarding all the interfaces of this router, then show interfaces command is enough. So show interface serial, and that particular interface name is given here. So you can see MTU is 1500 bytes and bandwidth is 1544 kbps and delay is 20,000. So that delay is expressed here in microsecond. While using this delay in formula, we need to use it tens of microsecond, means delay will be 2000, right? So this interface delay is 2000. Destination is here. So destination provided, that is router 2. So you can observe here this delay, bandwidth of this interface, that is 1544. Even this 1544, this is 1544. So what is formula? Formula is 10 raised to 7 divided by list bandwidth, right? So 10 raised to 7 divided by list bandwidth. So list bandwidth here, bandwidth is same here as the serial interface is used. So that's why bandwidth we need to use, that is 1544. 10 raised to 7 divided by 1544. Whatever answer will come, we need to add delay of outgoing interface. So delay is here 2000, and this delay we need to consider 2000. So 2000 plus 2000, that is 4000. Then it will reach towards destination. So you can see here the metric calculation, 10 raised to 7 divided by 1544. That value will be 6476 point something, that's 6839, plus that 2000 plus 2000 delay. So that is 4000. So and into, so this is called as cumulative delay. We need to add that outgoing interfaces delay. So this is cumulative delay. So 6476 plus 4000, that is 10,476 into 256. So we'll get this cost, that is 268,1856. So you can observe here 268,1856. So we have got the cost. So likewise, you can calculate EIGRP cost. So in the next slide, even you can see here, now this is source, excuse me, and this is destination. So now this is connected through serial interface, that router 0 to router 1, router 1 to router 2 is connected with serial interface, and router 2 to that server. So server is in the destination, so that is connected to fast Ethernet interface, right? So formula is again same. Now we'll see the bandwidth. Now this is serial interface. If the bandwidth is not set explicitly, so in case of serial interface, that bandwidth is 1544 kbps for serial interface. If it is not set explicitly, you can set the bandwidth in kbps. And here that fast Ethernet interface, which will have bandwidth 100 mbps, so that is converted into kbps, right? So what is formula? 10 raised to 7, 10 raised to 7 divided by list bandwidth. So list bandwidth on this route, that is 1544. So 1544 is considered. Now calculate the delay. So delay for this outgoing interface, delay is 2000. For this outgoing interface, delay is 2000. And for fast Ethernet, delay is 100 microsecond, means that is we need to consider tens of 100, that is 10. So 2000 plus 2000 plus 10. So 2000 plus 2000 plus 10. So cumulative delay is 4010. So here in the put that 4010 in the formula and we'll get so here we'll get 10,486 into 256 and just wait. So that is 10,486 into 256. So this cost will get, that is 268,44416. So you can cross check here, 268,44416. So likewise we can do the cost calculation. So in the next lecture we'll see how to configure EIGRP protocol. Then we are going to see how to configure EIGRP and RIPv2 on the same network. So that is your assignment. So that will complete, and even we'll see again cost calculation in that topology. So here that basic information about that EIGRP we have covered. So you can see here now I have given IP addresses to these PCs as well as router interfaces, and we are going to design here that EIGRP protocol we are going to configure. Design is already given, so there are total number of networks 10, 20, 30, 40, 50 and 60. So you can notice here that only one PC is connected, then 10 network, and we are going to see that whether this transmission is successful by using that EIGRP. So now 10, 20, 30, 40, 50, 60, just put the cursor on the router and check where that IP addresses are given. So IP addresses are already assigned to those interfaces, you can observe here, right? So only EIGRP configuration is remaining. So that EIGRP configuration, how to do that EIGRP configuration, that we'll see. Only some little bit difference in that RIP and OSPF routing protocol configuration. So we are in user EXEC mode, go into the privileged mode, then conf T. Now we are in a global configuration mode, and here you can configure a routing protocol, that is router RIP, no, not RIP, router EIGRP, and you need to provide some autonomous system number. Suppose that autonomous system number I have provided, that is 10. So router EIGRP and 10, that is need to specify that routing protocol EIGRP should be given, and 10 is a autonomous system number. So after doing this, what you have to do, you have to now add the networks. As I have used here classful network, so there is a now see 10, 20 and 60. So if the classful network is used, then there is no need to give wildcard mask while adding network. So network, then 10.0.0.0. So 10 minutes we can continue. Say 10.0.0.0, and next is network 20.0.0.0, right? So that is next network. Next is which is directly connected, that is 10, 20 and 60. So we can add network, that is 60. So here we have added three network, 10, 20 and 60. Now next task is what key after addition of that network, just come out from that. Then now this on this router we have configured EIGRP protocol. The next is Then again in CLI mode, repeat the same procedure, that is how en, then conf global configuration mode, router EIGRP, we have to give same autonomous system number, that is 10. So router EIGRP 10. Then which networks are directly connected, that is 20 and 30, right? So 20, that we need to add network, that network 20.0.0.0. So you can see here the neighbor adjacency is established. So dual 5, that is dual algorithm is used. IP EIGRP 10, it's a autonomous system number, neighbor 20.0.0.1, fast Ethernet, that interface which is connecting to that interface, and which is establishing new adjacency here, right? Again, next network, that was 30, that we need to add. So 20, 30, right? So this router is configured. 20 and 30 networks has been added. Now the next router, CLI. So check first which networks are directly connected, 30, 40 and 50. Enable. Then router, go into global configuration mode first, conf t, then router EIGRP 10, same autonomous system number. Then network 30, so new adjacency is established here. Then network 40 and 30, 40 and 50. Next network, that is network 50.0.0.0. So 30, 40, 50, these three network address has been added on that third router. So close it. So this router is also configured. Now the last router, that is router 3. So 60 and 50 are directly connected to that. So again, go into the CLI mode and repeat the procedure. Go into the global configuration mode, then router EIGRP process ID or that autonomous system number, that is 10. So router EIGRP 10. So complete that. And next, what we have to do? Next is we have to add the network. So network 50.0.0.0. So you can see the new adjacency is established here. And next is network 60.0.0.0. Then new adjacency. So clear with this. So here we have a configured EIGRP on all the 4 routers. All the 4 routers are established EIGRP routing protocol or configured EIGRP routing protocol. So we see the transmission here, that from PC0 to router 3 it is successful. Then PC0 to server it is successful. So you can check first, that will be failed. Now it is successful. Then PC0 to this router 1 it is successful. So transmission is successful among all these routes. So what we have to do, click on this router 0 for example and give the command show IP route. So where we need to give that command, that is on privileged mode. So that is router hash. So sh show then IP route. So you can observe here, to that router 0, 3 networks are directly connected. Those are 10, 20 and 60. And 3 are connected through EIGRP, that is 30, 40 and 50. So AD value is 90, as the routing protocol is EIGRP. So AD value is 90. So 3720, that is a cost. That to reach towards destination 30 from router 0 via this interface, that is 20. So you can observe here in this diagram. So this is router 0 to reach towards network 30. So we'll open this routing table. So to reach towards network 30, that cost required is 30,720. So as I told you, that cost calculation formula is what? That is 10 raised to 7 divided by least bandwidth plus cumulative delay. So if you notice here, fast Ethernet interface is used, and to check that fast Ethernet interface bandwidth as well as delay, you can give command show interface, and this interface name is FA0/1, FA0/1. So I can see the specification of that interface only. So if you observe here, that bandwidth is 100 Mbps, means that is 1 lakh kbps, and delay is 100 microseconds, so that is tens of microseconds. So delay we need to consider, that is 10. Are you getting? So here, that 10 raised to 7 divided by least bandwidth. So least bandwidth means both outgoing interfaces are having the same bandwidth, that is 1 lakh. So 10 raised to 7 divided by 1 lakh. So we'll get 10 plus this bandwidth, cumulative bandwidth. The bandwidth at this interface, that is 10, and this interface, that is 10. So 10 plus 10, 20, right? So 120 into 256. If you check here in the calculator, that is 120. See, 120 into 256. So that is 3720. So you can see here in the routing table that cost is, the routing table cost to reach to network 30, that is 3720. So you need to understand that formula, and you need to understand how to calculate the cost. But here, if you see here at the network 50, so network 50, so this is router 2 to router 3, that is network 50. So first you need to observe in the routing table, network 50 route is via 20. So that is what? From this router, router 0, via 20 means router 0, router 1, router 2, and then router 3 to reach towards this network 50. So here the bandwidth is, what is the bandwidth? 100 Mbps for fast Ethernet. Then same here for fast Ethernet, 100 Mbps. And here it is 1544 kbps, right? Because it's a serial interface. If you want to check, what you have to do, click on this router and exit and give command show interfaces. Give the interface name, that is serial 0/1/0, that is serial 0/1/0.